My name is Katrina Cernucan, and this is my pilot work examining the effect of a series of off-the-shelf, commercially available insoles and their role in static balance. My work was done in conjunction with Dr. Andrew Merriweather at the Ergonomics and Safety Laboratory at the University of Utah. According to the Bureau of Labor Statistics, there is an increasing percentage of individuals above the age of 65 that continue to work. Although older workers are much less prone to workplace accidents, they are much more likely to sustain severe or even fatal injuries should they be in one. To reduce this possibility, companies will often opt for infrastructure-oriented abatements, such as compliant flooring, to reduce the severity of fall injuries. However, there are certain circumstances where this is not feasible. For example, in warehousing, the use of heavy machinery would cause the floors to get ripped up, effectively rendering them useless. Rather than attempt to reduce fall injury severity, balance-enhancing insoles could be used to eliminate the possibility of a fall from occurring in the first place. Previous research has shown that insoles can be designed to better facilitate balance by enhancing the somatosensory or tactile feedback on the sole of the foot, or by redistributing pressure on the foot to mitigate pain. Specific elements have been previously found to improve the static balance of the elderly, such as 3D texturing, but no studies have identified the effect of insoles with multiple attributes. We hypothesize that an insole with texturing will more significantly improve balancing capabilities as opposed to a pair without using texturing. For our pilot study, we recorded static trials for 5 individuals below the age of 35 using full body motion capture. Participants were asked to remain as still as possible, arms crossed, for the span of 30 seconds, their eyes either focused on a target 2 meters away or closed. This was performed 3 times for each condition, with the 3 insole pairs and a control of non-textured inserts. The resulting data was processed in Visual 3D, a biomechanics software for the center of pressure, which is the theoretical point upon which the pressure of your body is centered, in the mediolateral, ML, or side-to-side, and anterior-posterior, AP, forwards and backwards directions. Our results found that during eyes closed conditions, pair A facilitated the largest improvement in the AP direction, whereas pair C, on average, reduced AP sway most significantly when the eyes remained open. Mediolateral ranges also exhibited improvements, however, they had substantially larger standard deviations. For the eyes closed conditions, pair C improved sway most significantly, and when participants' eyes remained open, pair D instigated the greatest improvement. Decreases in the center of pressure excursion, or sway range, in the mediolateral and anterior-posterior ranges are indicative of enhanced stability. To effectively balance, somatosensory feedback and vision are critical. When visual feedback was removed during the eyes closed conditions, pair A provided the wearers with the largest amount of tactile feedback by virtue of its large amounts of 3D texturing. During the eyes open conditions, texturing was not as critical, and the arches increased contact area of the wearer's sole to the insert. All insole styles improve the balancing capabilities of the wearers on average, with or without visual feedback. The current results are in alignment with our hypothesis. However, further research will need to be done to confirm these findings for additional young individuals as well as an elderly population. We will also intend to assess the center of pressure velocity in addition to the center of mass excursion and velocity. Moreover, we also intend to study the insoles' effect on static balance. If the final study results indicate the same conclusions, then these insoles and those with similar attributes can help improve balancing capabilities of its wearers. If applied in the workplace, then these insoles can be used to improve the balancing capabilities and by extension, safety of the aging work population. Thank you.